hit record, you need to have the table, because obviously 11 through 18 basically all work together back to that table. So be looking at the table as we go here. I think, if I remember correctly, somewhere in one of the previous problems, did they not suggest a year? Did they tell you specifically that you should not use 1954, but that you should use some other year?
They told us to use 1950.
No, it's telling you to use that year, but it's not saying use that as your t value. Anytime you were using years, you should make the first value t equals 0. Okay? Anytime you, and I can't believe y'all have ever heard that before, anytime you are doing problems with years as your time value, you should convert to the first year in the problem as t equals 0. Okay? So when we get to number 15, and it tells you to use the data for 1954, then my t value for 1954 is going to be 0, and then what? 32.3. And this is the female data, so we'll put a little F there to denote that. And then the other female point, to say, because you're going to write in one line for the female data, one line for the male data, right? Then 1999 is how many years from 54? It's not a trick question. It's 45. All right, and the female number for that is 58.5. So there's your x and x and y and y, or x and y, as Kobe said. All right, so if we are to write, and it tells us to write it in slope-intercept form, well, the beautiful thing here is that if I'm writing it in slope-intercept form, by creating this format of using the years since 1954 as my x value, get my b for free. Do you see that? My b is 32.3, so all I need is a slope. Yes? So let's get our slope together. So then our slope is, and it doesn't really matter which one you start with. I used to do the one most students don't use first, but I'll go with the second one first. 58.5 goes with 45, and jump in anytime. 32.3. When I pause, I'm not having a stroke. I'm trying to see if you're actually with me. Then 58.5 minus 32.3 is 26.2. And obviously 45 minus 0 is 45, which gives us an ugly slope of converted to a decimal, because that is a fresimal. We cannot leave it that way. There are no such things as fresimals, except in the land of unicorns where math does not exist. Anyone can tell me what this is? It's 0.58. Do y'all agree with Ryan? I only heard one emphatic answer. 0.58. I would recommend that you put the 0, and I would also recommend that you pay close attention, and you will see this when you get your test back, to things like making sure that your decimal is clearly a decimal and such as that, because you're responsible for every mark on the page. So then, because we're writing two equations in one problem, a smart way to do it is do y subscript f, which stands for the female data, equals 0.58 plus 32.3. And my work here is done for that one, right? So then the y subscript m is going to look similar, yes? Okay, so now I have to get a new batch of data. So let's get a clean screen to work with and do the same thing. So now we're going to come back and get the starting point, which is 0.83.5. Did I not put an X behind it? Oh, my bad. That was my oversight. Yeah, we could put an X there, because that's our T. X and T, kind of interchangeable there. Yes?
Yep.
All right. And then the other point was 45. Okay, my pen is arguing with my little screen here. 45, and my males at that point is 74.0, and I'm just going to go ahead and leave that 74 because that's all that is, right? So once again, I need the slope, and again, this is you could subscript M that as well to make it clear, especially if you kind of tend to work in a scattered way, which I want to get you out of, but that might take some time. So we're going to have 74 with the 45, 83.5 with the 0, 74 minus 83.5, negative what? 9.5 over 45. Oh, that's nice. And then that equals negative what as a decimal? 0.21. So then our male equation, y sub m equals, and our slope is negative 0.21 x, and our y-intercept is plus 83.5. Now, you could have eventually gotten to roughly the same equation, and I say roughly because when there are decimals involved, a lot of times you have a slightly different variation if you rounded something, by doing this with a lot more work, as in leaving the years as years, but it gets nasty. So obviously that's a very important thing to remember. Any real world application problem involving actual time, the starting point in the problem is t equals 0, unless the problem specifically tells you otherwise, okay? So let's talk about the difference in these two equations, because that's all we had to do was write the equations, right? Or were we supposed to use that?
In 17, you have to use the...
Yeah, but for 15, that's it, right? Okay. What makes sense about these two equations if you look at the way the table is behaving? Right, okay. So the slope of the female equation is positive, which tells us what? Although we started with fewer at the beginning, what's happening to the number of female workers? It's increasing, and the number of male workers is decreasing. And why would that make sense from 1954 to 2004? Women in the workforce, right? I mean, if you've studied any history at all, that's pretty, oh, so I have to do 17 also? Why do I have to do 17? Now, these are like baby problems, of course. So was letting teeth was... Just so you'll know, Kobe, my adolescent pacifier is a fist. He's like, no more crying from me. Yes, sir.
Please tell me that's on recording.
It is. Yes. You can play this for your parents. You're like, my math teacher really is insane. Listen to this. Okay, 17. At least she's aware because she just said so on tape, right?
Hi, Mom.
Oh, no, what's funny is when I told my calculus class that PT, y'all know PT Joseph, right?
Yeah, we do.
Yeah. He started texting me over the weekend for help with math. You know, he's off at school in Virginia. And I helped him via text messages over the course of 2 or 3 days. And then when I was first getting sick, I think it was the night it was either Tuesday night or Wednesday night when I was feeling like death. He started texting me and asking me questions. And you won't understand how profound a question this is, but he asked, what is a limit? A limit? A limit in calculus is something you spend about 3 weeks figuring out what it is. He wants me to explain in a text message what it is. So I gave it my best shot. We texted back and forth for a few minutes. And then I didn't hear from him for a little bit. Then he asked me a couple more questions. And then at 9:40, he texts and says, can I call you? And I texted him back. Because one of the things I had said was you should probably watch the videos I have posted on my calculus page. It would help you far more than, I'm going to be able to help you here. He texted me at 9:40 p.m., can I call you? To which I replied, I'm about to go get in the shower and get ready for bed. Which wasn't really a lie, but at the same time, I was ready to go. I was exhausted. I was like, I don't even like to talk to my sister on the phone at 9 o'clock at night, or one of my own children. I didn't want to talk to PT that night. So I was telling my calculus class the next morning. So and when I told them that I was sharing their videos with him, Mackie was like, can we like shout out to him? I was like, okay. So throughout that particular video, there will be shout outs for PT if he watches. So y'all can shout out to your parents if you want. Just don't make it a habit. Number 17. Oh, when we get to limits in here, you're going to be like, oh, this is what she was talking about. Number 17. If the percentage percentages continue to follow the linear models you found in exercise 15, when will percentages, oh yeah, I remember this problem now, of women and men in the civilian workforce be the same? How could we ever decide that? Oh, I know you did not just say, let's plug some numbers in to see what happens. Are you alright, Delaney? Are you about to assault Josiah? Oh, well, I actually got the fly swat out so it quit flying around my desk. So that's over there. Okay. Anybody have any intelligent thoughts on how we might proceed for 17?
I drew a line of best fit.
Okay, so Elizabeth said, let me translate what she just said. Elizabeth said, I use a graphical approach. The problem with a graphical approach is that it is a rare thing to have a truly precise graph, particularly of real data, right? And on these kinds of numbers, it's hard to get a precise graph. So that means that if your graph is really an approximation of the situation, and you use your graph to answer a question, your question then gets answered with another approximation. So in essence, it's almost like an approximation of an approximation, right? Because then when I graph the lines and look at the intersection point or something like that, but yes, that's the graphical approach. Not invalid, but Hannah, you had your hand up too. Yes, thank you, Jesus. What's the left side? What's the women's side? It was what was my slope on that side? 0.58x, and there's an 8 there that I'm trying not to draw for some reason. 0.58x plus 32.3 equals negative, was that 0.21?
Yeah.
X plus 83.5. Now, you could do this however you want to, but what I teach my Algebra 1 students when I teach equation solving is that when you have an x on both sides, you should eliminate the smaller one. So if we add 0.21x to both sides, 0.21 plus 0.58 is what? 0.79x equals, because we're also, having moved the x terms to the left, we're going to get that constant out of our here all in one step. So we're going to also subtract 32.3 from both sides, which will give us, what is it? 51.2. And then obviously we need to divide both sides by 0.79x and get 69.56.
Are you okay?
I'm just writing what I'm hearing. Y'all are actually doing the problem. I'm just recording. Is this correct?
When I divided 51.2 by 0.79, I got 64.8.
Okay. That's not what I meant to do. Sorry. So let's erase that. That's why it's important that everybody type this in your calculator. Because if you're always letting that one guy or girl or a little group answer the question, you may or may not agree with them. So you got 60 what point what?
I got 64.8.
64.8. So is everybody good on 64.8? Everybody concur with that conclusion? All right. Well, since our X or T represents what? Years since 1954, you can have that on your screen and type plus 1954 to get the year. So they would be equal in what year? 2018.8. Let's talk about the implication of that. Now that sounds a little crazy, but that's mathematically where we are, right? Well, what would the 0.8 indicate? Okay, well, when does it become 2018? On January the 1st, right? So 0.8 would be 0.8 of a year. So that would still be during, okay? So I think what I would say, instead of actually putting the 0.8 on my year, is, and you would be more accurate if you said during 2018. Now, if you just like to play with things like this, you could take 0.8 times 365. What is the significance of 365? Days in a year. So that would tell you on what day it happens. If you wanted to be, you know what I'm saying?
292nd day of
It'd be on the 292nd day. All right, so then you would have to subtract off the number of days for each month, and since that varies, that gets a little tedious, and then you could actually come down to a calendar date, couldn't you? But we don't have to go that crazy. Now, but I think this is what messed y'all up on the 69.9 part. The other question was, what percentage will that be? Okay. Well, if I know it's going to happen when x equals 64.8, how can I figure out what my percentage is?
Call it 64.8.
Into y?
Because it'll be the same.
Exactly. Well said, Mr. Kelly. Well said. Well, apparently it's just me and you, buddy, because the rest of them are like,
We don't.
okay, he said, okay, we got an answer. Where did we get the answer? We got the answer by setting the two sides equal to each other, yes? Because, as Elizabeth pointed out, which would be the equivalent to if you graphed the two lines and then look for the point of intersection. Yes? Okay. So we now know where that happens, which is when that happens, right? In this problem, in this context. All right? Well, so what that says is that we've just figured out where they're equal, which means that if I want to substitute it back in to figure out my percentage, it doesn't matter which side I plug it into, right? Because I'm going to end up with the same thing, because they're equal by definition, which is how we got there. You follow me? You look so excited to be there behind me, following me. Okay, so what do you get when you substitute back into either side?
69.
That's where the 69.9% comes in.
So that's the answer, or
64.8 is the when it happens, because the questions were, and this is where make sure you answer the questions on a test. So if I gave you this for a test question, you should say, okay, did I answer this question? When will they be the same? Yes, we answered that with they will be equal or they will be the same in 2018, right? And then the other question was, what percentage will that be? 69.9%, yes.
Is it alright to make little notes on your homework?
Absolutely. And in fact, I encourage students to develop the habit of anything that was added, and this is just for your own benefit when you refer back to your notes for later, is if you will, any annotations you put on your homework from discussion, you should put in a contrasting color. So like maybe do it in ink. Because then when you're studying for a test, you can come back and go, oh yeah, that was that whole set I had to completely redo. You know what I'm saying? That way you'll know what you need to study. Where by the end of the chapter something might seem simple, you might forget what you went through to get there. You know what I mean? And that you need to go back and make sure you're clear on all that at that point. Yes, absolutely. Always. All right. That's a sign of to me that's a sign of a good student when you do things like that. A sign of somebody I want to ask why they're in an honors class is when they turn in homework with wrong or missing answers to things that we went over together. That makes me cranky. 31. And that's sort of arrogant if you think about it. Number 31. Really? What's wrong with you kids? Everything is wrong with you? No, that is far from the case. We have 2x squared minus 5x plus 2
Bless you.
equals. Have we talked about the whole pagan blessing thing?
No.
That's a pagan habit.
Yeah.
Did you know that?
I understand the story behind it, actually.
I just like saying bless you.
Yes, but what a strange time to do it when someone's having a bodily function.
Oh, literally, I know, because they think, I forget what they think, but they
The
think
pagans
does that
thought
thing.
that every time a person sneezed, a little piece of your soul left
Yes.
you.
And so they bless
So,
you.
as a math person, I'm saying, well, at some point, you're going to drop dead from a sneeze, right? Because the last piece of your soul leaves, that means your body stops.
Unless it's a really, really strange piece. You have
So-
Or, if it was half the size of the previous one, you'd never lose all of it.
yeah.
There's a math thought for you. Okay, here we have, okay, why am I doing this problem? Talk to me about this problem. Okay. That was like 20 people, stream of consciousness. Well, I wanted you to do it because, and it's like literally every person is talking at the same level from their own personal perspective, which told me nothing. Okay, do we not know how to start it? Did we do it and get the wrong answer?
I don't know why it's up there.
You spoiled.
Okay, guys, we need teamwork.
Okay, the way to decide how to approach an equation in terms of its solution process is to look at it, consider what it is you're writing on the page as you write it. This is what kind of an equation? We see a quadratic on the left, and then we see what is going to be quadratic on the right. Yes? Why is it going to be quadratic? Well, and really it is quadratic, but less obvious. Because the first thing we're going to do, okay, let me rewind before I write anything further. What is the very first step, regardless of the method I ultimately use, what is the very first step to solving a quadratic equation? Get all the terms on one side. And then once you do that, you should hope it's factorable. And if it's not, then you can either complete the square, or use a quadratic formula, or use a calculator to graph it and solve it. The directions here tell us to solve algebraically and confirm graphically means that we should not reach for our calculator until we have solved it on paper.
So we didn't need to graph it?
Well, whatever the primary one is what you should put on paper. So the algebraic method I should definitely see done in full detail. If this said solve graphically, you're free to use your calculator if it's required, and sometimes it is and sometimes it isn't, but you're free to do that, but you should draw that picture that you used if you used the picture to get your initial answer from it. Does that make sense? In this case, we're going to confirm graphically, so we're going to verify what we get here using our calculators. Are you with me? So you don't have to draw the graph on the page. If it's a confirmation of your answer, you don't have to draw it. Okay, so I'm just copying the left side on this first step. On the right side, I'm going to expand. And yes, gentlemen, whom I have harped on the fact that you're not showing me enough work, this is a required step. Because I'm not doing it for me, I'm doing it to show the world. Now, one thing you need to show me that you've developed some mathematical maturity by not showing me both the O and I terms on paper. Okay? So when you expand this, you should be able to expand it by looking at it, because the middle term simply comes from negative 2x minus 3x, which is minus 5x, and then plus 6 plus 3x. And I'm really going to be glad, Nick, when you get that test made up, because I keep wanting to refer to crazy errors I saw in that I can't until you do. So he was going to, but he's got an appointment that has conflicted with that. All right, so now I'm going to combine like terms over here, and I get x squared minus 2x plus 6. So far, so good? Now I need to move everybody over to one side. So I'm going to subtract x squared, which is going to give me x squared as my leading term. I'm going to add 2x, which is going to give me minus 3x. And then I'm going to subtract 6, which gives me minus 4. Hallelujah, it is factorable. Yes? X minus 4, x plus 4, I'm sorry, x plus 1. Yes? So then my answers are 4 and negative 1.
Yeah, I got that one.
Fabulous. So we're going to pause the video for a second because it says we're cooking with gas now.
Let's just not.
Can we just skip that?
Yes, let's skip that one.
Yeah. Let's go to the.
What's the next real one we need to talk about?
39.
It's freaking out. Okay, well, the first problem we have is that y'all should have resolved this during your discussion, right? All right, so we're arguing over 37 and 39. Well, they're two completely different problems, but similar in a way, right? Okay, let's look at 37, and then we'll see if we want to look at 39 as well. Let me just ask, will you be honest if I ask, was it the square root that scared you?
Yes.
Yeah. Got an honest answer there. Silly kids. It's just a square root. All right. So x plus 1 minus 2 times the square root of x plus 4. Now, of course, we haven't been together very long, so I have to refer to just what I know you've seen. How did we solve? Somebody tell me how to solve an equation that's the left side is in vertex form.
And the other side vertex. Why would you do that?
You take the
You take a square root.
Let's just say, Todd, that I have the left side is vertex form and the right side is 27. Do I want to make 27 into vertex form? I can't really do that. It's just a number, right? Okay. So how do you solve something in vertex form? You would, if there's a plus or minus number, you would get rid of that first, and then you would divide off the constant, which you didn't know when you took your test. And then you would do what? Oh no. Oh no, no, no. That would defeat the purpose of vertex form solutions. Take the square root. Yes? Okay? So in essence, all that gobbledygook we just said, the first step of solving something with vertex form involved is to isolate the square binomial. Agreed? So the thing that terrifies you here is the square root. So the first thing is to isolate the square root. Because if I isolate the square root, how can I make it go away? Square it. Okay? All right. So let's do that. So if I'm going to isolate the square root, what would be the first thing I need to get rid of? The x plus 1. So let's subtract that from both sides. And when we do, we're going to be left with negative 2 on the square root of x plus 4 equals negative x minus 1. So far, so good?
Yep.
And then we're going to get rid of the negative 2 by multiplying through by a negative 1/2. And that will leave us the square root of x plus 4 equals positive 1/2 x plus 1/2. Yes? And then we square both sides. And we get x plus 4 equals, and then we get 1/4 x squared plus double the product of the 2. Yes? Because I'm multiplying by a negative. Reciprocating a number does not change its sign. You get that in your head when you're thinking about perpendicular slopes because it's the negative reciprocal, but a reciprocal is just the inverse of the number. The sign stays the same. Okay? All right. Plus, so we had 1/4 x squared, so it would be plus 2ab, so it's double the product of the 2. So that would be double 1/4 x, so that would be, what's 2/4?
1/2.
1/2 x plus 1/4. It's big boy math. You should appreciate it.
I was like, what is she doing? Oh,
I expanded the binomial, which is what y'all should be doing. And I actually slow-moed it and talked you through it to show you what I was doing. Because y'all need to develop that as a reflex. It needs to be like fast and accurate. Okay? I shouldn't see your FOIL terms. Makes me want to spit. All right? So then I'm going to subtract these other little terms over here, so we'll all be one big happy quadratic family on the right. Because this is a quadratic equation and that's how it works, yes? So we have 1/4 x squared, and then when I subtract x, now I have negative 1/2 x. And then when I subtract 4 from 1/4, I'm subtracting 16/4 from 1/4, which would be negative 15/4. That should be, I don't know,
Oh, I got it.
5th grade math.
You didn't even do it.
Yes?
Wait.
No.
Wait, 5th grade.
It should be. I didn't say, you failed. That's what the system failed you. Which part did I lose you on?
The middle part. What happened?
I don't know what the middle means. The middle of what?
Like, what made it negative 1/2?
Okay.
Maybe I-
Well, the 1/4 x squared, why did he not change? Because he's the only square, so he doesn't combine with anybody, right? But then we have this plus 1/2 x, and what did I have to do? I had to take away a whole x from a half x, which puts me 1/2 in the whole. Yes? Negative? Am I speaking too quickly? Go watch the tape over and over until you hear it. All right? And then if I have 1/4, I have to subtract 4, right?
Yes.
Well, let's come over here and do that in slow-mo on the side. 1/4 minus 4. Yes? Which is the same thing as 1/4 minus 16/4, using the common denominator approach, which is minus 15/4. Are we good now? Okay, cool. All right. And then I need to solve this. right? What's bothering you still? Fractions. Well, when you can, you should kill them. And I'm going to show you how. I did say that. Okay? So, what is the least common denominator of halves and fourths?
4.
2 is not a common denominator. Okay? The least common denominator would be 4 because both 2 and 4 go into 4. Understand? So I'm going to multiply. Now watch this, and I'm going to write it in a different color to emphasize the importance of knowing this. Maybe I should use a different color against that green background. That might be too dark. Okay. I'm going to multiply both sides by that least common denominator. And when I do, I get 0 on the left. And when I distribute that 4 on the right, I get x squared. What's half of 4? 2x. And then it cancels the 4 off and leaves me this. Better? Much. Not only is it better, you can factor it. Okay? So we get 0 equals x minus 5 times x plus 3. So our solutions, based on what we've just done, are 5 and negative 3. So far, so good? We're going to confirm graphically. To explain what an extraneous solution is.
When you go back into the original.
Raise your hand, Elizabeth.
When did we start? Have we ever raised our hands in here? No, we don't. We're just one big happy family having a chat around the dinner table. All right? When we substitute, when we get two solutions, or sometimes both of them are extraneous, they both fail to work in the original equation, right? So an extraneous solution is one that fails to work in the original equation, all right? But it results from legal algebra. Wasn't everything we did legal algebra?
Yes.
And if you aren't 100% confident, I will tell you, in fact, that it all was legal algebra, okay? But I will tell you why it happened, okay? Anytime you multiply by anything with an x in it, you create the possibility of an extraneous solution coming out of your process. Because let's go back to the original equation. This original equation was not quadratic, was it? It had a square root in it. So basically it's like a quadratic on its side, but only the top half, right? Isn't that what a square root graph looks like? Okay, if y'all don't know that yet, you'll know it later. All right, so I wouldn't necessarily expect two answers, right? But I got two answers because I made it quadratic. On what step did I make it quadratic? When I squared both sides, right? So by squaring both sides, in essence, I multiplied by a factor of 1/2 x plus 1/2 in a way. You see what I'm saying? So by doing that, I created the quadratic that wasn't quadratic. That's when that happened, okay? And we'll actually do a lesson on that later. So we can say, and this darn thing didn't connect. I'm mad at it now because it missed all that genius conversation. I have to come over here to the computer. It's found itself again. All right, so what do we know from our graph that we didn't think to check before we got our graph out?
-3.
Right, so -3. So the only solution is x equals 5. -3, x equals -3 is extraneous. Now if you write that as your answer, and that solution looks terrible. If you write that as your answer, anybody that understands math would understand what an extraneous, you don't have to explain what an extraneous solution is. You just need to understand what it is so you'll know when to call something extraneous. Kind of like when you take a test on factoring. You can put cannot be factored if it actually cannot be factored, but if you're putting it on every one, that's not a good sign. Yeah, same sort of thing. All right, let's go to 39. You hear the enthusiasm in my voice, right?
Yay.
All right, 39. We have 2x minus 5 equals the square root of x plus 4. By the time you get to this point in the assignment, what I would like to have happen in your head is that when you look at the left, what would that be if I graphed it? A line. Yes, it's linear. because I don't see a square, I don't see any absolute value bars, no square roots. It's a line, yes? And the right side is the square root, yes? Okay? So, again, I've got that picture in my head. So, at most, how many places could a line and a square root intersect? Could be 2, right? If you're not thinking in specific details about this graph. So that's how you should be thinking. And you may or may not be there yet, but that's the ultimate goal. All right, so we already have our square root isolated, so what are we going to do first? Square both sides. So we're about to make this thing square, so what's a good possibility that's about to happen? We have to check for extraneous solutions when we get to the end of this. So 4x squared, what? Minus what? Minus 20, very good. Minus 20x plus 25 equals x plus 4. Okay, and then I need all my terms on one side. The x squared term is going to stay the same because there's only one of them. I'm going to subtract the x off and get minus 21x. Subtract the 4 plus 21 equals 0. Yes? You special. Okay, and then I want to factor this, yes?
Yep.
All right, in the interest of time, I'm going to cheat. Well, Lord, y'all gave me a whole assignment to do, so, not again what?
It's answer to.
Okay, so we'll keep it inside. I'm sorry. Sometimes the old volleyball player in me can't resist a good set. Factor, and that was 4x squared, right?
Minus 21x plus 21.
Oh, not minus, sorry. Minus 21x
Plus 21.
plus 21. Not factorable. Didn't think it was. Yes? That confirms that it's not. So if it's not factorable, quadratic formula or preference.
Quadratic square.
No.
I like the formula.
Okay, well, choose it, solve it by the method of your choice now. Go. This one's going to be kind of nasty for completing the square because you got to factor 4 out of 21. Have fun with that. Quadratic formula is
Negative b.
negative b. Watch this. Watch how, and I'm going to say, I want you to watch how I write it when I use it. Negative b minus.
Yeah.
Oh.
Stick with roll.
What?
The screen.
No, watch. Nothing. It's magic. It's invisible. All right. So I didn't put letters. I put parentheses. Negative b plus or minus the square root and put a big square root. And what's inside the square root? B squared. So I'm going to put parentheses squared minus 4 parentheses all over 2a. So I'm putting 2 parentheses. Because now, and the reason you should put parentheses is that if you start plugging in negative numbers and you don't put your parentheses in the right place, you will get the wrong answer. And that is very frustrating because this is tedious enough on its own. Do you not agree? All right. So now, what is my, what's the first thing? The b? What's b? So I'm going to put a negative 21 here and a negative 21 here. No, that's not where it goes. Where else does it go? Right here. They go side by side, right? All right. And then the next thing I see, what comes after the 4? A, which is 4. So I'm going to put a 4 here and on the bottom. And the only thing left is the C, which I didn't leave myself room to write. So I'm going to erase that last parenthesis off. Sorry. Let me get the blue color back so I can fix what I mess up. And the C is 21. Yes, that's why it's up there. And there's an 8 on the bottom and a positive 21 plus or minus. What is 21 squared minus 16 times 21?
105.
Altogether it's 105? Okay, can that be simplified? Hmm?
Yes.
again, to speed us along, I'm going to let the calculator do it so y'all can see if it came out right. All right, so I'm going to menu algebra solve. 4x squared minus 21x. I don't know why I did that. There's a smarter way to do this. Let me do it. I'm going to up arrow, enter, bloop, equals 0, comma, x, bloop. There's my answers. So basically it's just the exact forms are those, okay? So what you've already written, if you've got 21 plus or minus square root of 105 over 8 are the two exact form answers. If you want the decimals, there they are. Approximately 1.344 and 3.905. Okay, so that's that one.
That was a good one. 41. No time.
I will tell you that 41, you might want to wait for this. 41 and 43, there's no like really nice way to solve those unless you remember how to factor cubics. Even if that one turns out to be a factorable cubic, you may solve those just graphically. And it tells you in the directions to solve it graphically anyway, so we were kind of doing these the same way we were doing the other ones. The directions, starting with number 39, you're supposed to solve them using your graph. And these are calculator questions because they don't have gray bubbles on them, okay? But the analytic practice was good too. So you should show me a picture for 39 through 45 because graphically was the first method it named. Yeah, so go back and put a picture on it if you haven't. Bring that tomorrow. You will start with section 1, 2 in your groups tomorrow, okay? Yeah, get that wrapped up and ready to turn in. Yeah, wait and turn that in a minute.
Which ones do we need?
Did you have the graphs on there? Yeah, so there you go. The ones that say 39 through 46 because it says solve graphically. Bye, Hannah. Oh, thanks. Oh, that's cute. That's